Hello everyone. In this video, I'm going to give you introduction to projection of point, and along with that, I will give you bird eye view of this engineering graphics subject. First of all, we will see the little mathematics behind all these entities, that is point, line, plane, solid. Okay, as you know, point is a dimensionless entity. Point, it doesn't have any dimension. Point is a dimensionless entity. Point doesn't have any dimension, but just to represent the point, we indicate it by a dot, a small tiny dot, but actually it doesn't have any dimension. If we keep infinite number of points one after another, what will happen? We get a line. Then what is line? It is the collection of infinite points, and irrespective of its position, line has only one dimension. It may have length if it is horizontal, it may have height if it is vertical, and it may have width. This is also horizontal, but it has some different orientation perpendicular to board. Out of these three dimensions, it will have only one dimension at a time. Point, it is dimensionless entity. Line has a one dimension. It is single dimensioned entity. It is single dimensioned entity, and it is formed by the collection of infinite points. After this, we shall talk about plane. Let me write this line first. Line has one dimension. One dimension. If we keep infinite number of lines one over other, then what happens? Then plane is formed. Okay, we can keep lines one over other, or we can keep lines one by one, one after another. In this way, we will have a plane. Then plane is a two-dimensional entity. It will have length and breadth. Okay, it is a two-dimensional entity. Two-dimensional entity. After this, solid comes. Solid comes. Okay, what is solid? If we keep infinite number of planes one above other, then solid is formed. Then solid is formed. Then solid is formed. We can take example of book or notebook. Book or notebook is a collection of a number of pages. One page you can call, or you can consider that as a plane, and collection of a number of planes will give a three-dimensional book or notebook, which will have length, breadth, and height. What is solid? It is a collection of infinite planes, and it has three dimensions. It has three dimensions. It has three dimensions. It is very interesting to know that everything from something, nothing. Point is what? Nothing. Nothing. But source of all remaining entities, that is line, plane, and solid, is point only. The source of all these entities, that is line, plane, and solid, is point only, which doesn't have any dimension. Everything from nothing. we got all these entities from nothing means point. From nothing means point. Very interesting thing. Okay. Therefore, to learn this subject, learning this subject means we are supposed to learn projection of point, then projection of line, then projection of plane, then projection of solid one by one. After learning all these entities and many lessons allied with these entities, uh, we understand this subject. Now, one more very important thing I am going to tell you. First, we are supposed to learn the projection of point, means where is the point located, whether it is in first quadrant or third quadrant. Normally, we use first and third quadrant. Not all four quadrants are used. Second and fourth quadrant is not used. The reason I will tell you later. But for time being, in this video, we will discuss all the four quadrants for the projection of point. If the point is in first quadrant, now let us draw quadrant, first quadrant. See, this is horizontal plane and this is vertical plane. Okay, how this quadrant is formed? See, if we take vertical plane and horizontal plane, okay, keeping these two planes at 90 degree, we get this reference line, that is line common to both the planes. This is horizontal plane, this is vertical plane. By using these planes, we get four quadrants. This is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Now let's talk about projection of point when it is in first quadrant. When it is in first quadrant, if I place point in first quadrant somewhere here, to specify this point, I need to tell the location of this point using two coordinates, means two distances. The distance from vertical plane is x coordinate, and distance from horizontal plane is y coordinate. To specify this point, I need to tell this information, that the point is so and so millimeters above HP. What wording should be used? Point is above HP. Point is above HP to give y coordinate, that is the distance, vertical distance. And this is not enough. In addition to that, I need to tell how much away this point is from vertical plane. That front distance gives x coordinate. That front distance gives x coordinate. Therefore, to specify point in first quadrant, okay, first quadrant, what language should be used? Above HP, and in front of VP, in front of VP, in front of VP. Now let us consider point in second quadrant. If I place point in second quadrant with reference to these two planes, how to specify this point? There will not be any change in vertical distance specification, that is point is so and so millimeters above HP, but there will be little difference in wording. Okay, it is how much behind VP. Now if the point is in second quadrant, it will be behind VP. Therefore, for second quadrant, the specification should be like this: above HP, and behind VP, and behind VP, behind VP. Now, if we keep point in third quadrant with reference to these two vertical planes, these two reference planes, HP and VP, see how to specify this point, how much it is below HP and how much it is behind VP. What wording should be used? Third quadrant, below HP and behind VP, below HP and behind VP, behind VP. Now let's go to fourth quadrant. If I keep point here, then what should be the specification? Below HP and in front of VP with reference to these two reference planes, that is horizontal plane and vertical plane. What should I say? Below HP, in front of VP. Below HP and in front of VP. These are the specifications of point in different quadrants. In addition to these four cases, there are some special cases also. The point may lie on horizontal plane or vertical plane, and the very special case is the point is lying on both the planes, means it should lie on this XY line. Both these cases we will discuss in the next video, and we will try to solve the problems on projection of point in the subsequent, means next video. Thanks for watching. We will meet again in the next video. Till then, goodbye.